Be live any second now. Okay, I think we're live. Hello, anybody out there. The comment from Builder is from me, so I am Builder. If you see comments in the live chat from the Builder logo, I should probably change login to be me so people know. But welcome to our stream today. We're going to talk about mitosis versus web components. We'll explain what both are, the trade-offs, and a bit of background, like why we're creating mitosis, why we tried web components for a certain use case and realized there was a missing sort of layer that mitosis can help fill in. If you're joining in, please drop in the chat like who you are, where you're from. It's really nice to just hear from you, get to know you, ask questions like crazy. We like to cover things that are interesting, not just theoretically interesting or interesting. There are certain things that like Mishka and I or Sammy and I will find interesting that nobody else will, so we'll try and stay on topic. So without further ado, you probably already know me, Steve, and Mishko. But Sammy, you want to jump in and introduce yourself? Sammy, just so you all know, he's an engineer at Builder. He's working on mitosis like crazy. And tell us a little bit more about you.
Sure. Hi, everyone. Yeah, my name is Sammy. I'm a software engineer at Builder. Been here for like just under a year now. Primarily started off with like doing data engineering and then found that to be extremely ungratifying. So I switched to being a web developer, which is very cool, all things considered. And after doing that for about 4 years at another startup called Unsplash, I joined Builder. And so my work went from just building a React web app to building much more meta abstracted layers on top of web frameworks, like working on Mitosis, which, so I've been working on Mitosis like half the time, and then the other half of the time building our new generation of SDKs, which are built on top of Mitosis. So that's the primary reason why I'm investing so much time in Mitosis, is to get our SDKs to a place where they work for Vue 2, Vue 3, Solid.js, Svelte, React Native, React, Quick. I think that's the list of everything that compiles right now, which is much bigger than it was like 3 or 4 months ago. But yeah, that's me.
Yeah, thanks for that, Sammy. And yeah, if we're talking about what mitosis compiles to, I actually have it in front of me. We also have, I don't know if we mention React Native? We have experimental Swift, Solid.js, Stencil, Marco, Preact, Lit, raw web components, raw HTML, liquid, template strings. You can compile to Builder. Anyway, we'll go into like explaining what this is. Why don't I maybe start there and give a tiny bit of background on these two things? So maybe a little bit of backstory on why we're making mitosis will explain sort of what the use case is, and allow us to explain sort of how it works, because I think it's a little bit interesting. I think like all projects or many projects, mitosis was a bit discovered. I sometimes think that people don't really invent things. You just kind of discover a pattern. You kind of fall into a pattern, realize, oh, this kind of works. And it wasn't really, I mean, other people could have, under similar circumstances or eventually over time maybe would have. So we have this problem at Builder. So for those who don't know, Builder is a drag and drop editor you can connect to any tech stack. The goal is, I actually give this briefly too. I mean, the goal is to solve a problem I had at the company I worked at last, where we had this gigantic Angular site, shops.com, e-commerce site, super tons of functionality, right? Engineers building components for all sorts of stuff. Yet parts of the site, like the homepage and landing pages and promotional regions throughout the pages, constantly needs to be updated by the marketing team. Not just simple updates like, hey, we need a button or we need something static. It was like, we need something and it needs to change all the time. It needs to have new buttons, new images, and then we need to run A/B tests. We need to personalize. If you're shopping menswear, you'll see men's oriented content, women's wear, women's footwear, stuff like that. And that was wildly tedious for us to build all of that. And the structured data style of headless CMS, which is the predominant style today, was far too restrictive. What we really needed at the end of the day, I remember being stuck on how much engineering hours we were putting into these things and how much tension that was creating between engineering and marketing. The marketing team couldn't add something on the website that was net new without like weeks of lead time because of backlogs and all that. And engineers hated the work. I mean, just adding a button, removing a button, it got tedious. And so eventually we're like, hey, if you think about it just as an engineering problem, it's an input-output problem. Input needs to be drag and drop like a Webflow or Squarespace, and output needs to be high-quality Angular code somehow. I mean, if you could do that. And so that was the genesis of Builder, which is, well, how do we make a drag and drop where you can take your Angular components, drag and drop with them, and integrate that onto your website that supports everything you expect: server-side rendering, performance optimization, very lightweight, simple integrations and SDKs, and remove all that manually managing, updating, etc. code based on what the marketing team, product team, whatever needs all the time. So engineers focus on complicated things like our product sales were wildly complicated, right? Or our search rankings. We would focus on that instead of buttons. The marketing team could just drop in a button, hit publish, and it goes live, and still stay consistent with our design system, token standards, all of that. And so that was great. And Builder originally just supported Angular. And then we added support for React. And so we had to build a set of SDKs in React components. And we were managing two sets of components, React and Angular. And that got very time consuming, especially when you realize that now Vue is very popular too. And there's others. And we're like, the components that render components and the built-in components like images and columns and buttons and forms, it was very, very difficult to maintain and build all those things. And we couldn't even foresee how we'd support future frameworks, though we know it would be necessary. And then when it came to performance optimizations, having to repeat it across everything, it was a lot. So the next thing was like, I caught the web components bug, meaning I got excited about web components. But web components was going to be the way that we build one set of components in a browser native standard way, and those would work for every framework. And I was jazzed. And so I started moving everything to web components. The SDKs, all the primitive elements, all the rendering elements, everything was web components. And then we ran into a number of issues. The biggest one was server-side rendering support. So the biggest problem is web components are browser standard that heavily rely on utilizing the browser's main thread, right? Like the simple hello world example is class, my custom element extends, HTML elements, and then you add your stuff. And then you do register, I forget the registry name, but there's a, register custom elements, you pass in your tag name and class, and then the browser in the client orchestrates all of this. That turns into one huge problem when everybody wants to use this with Next.js and Gatsby and Angular Universal. And they want that page to have a fast FCP and LCP time. So they need all of that content that I was writing for just the browser main thread. So post, loading in the browser, they want that display immediately. And so that kind of created a big issue. And people start saying, oh, you can server-side render web components. And that's true-ish, but once you start trying to rig in your own server-side rendering system and integrate that with other server-side rendering systems, like yours is maybe async, but React requires synchronous, or now suddenly people are, one key feature of Builder is you register your components, so you can drag and drop with your React components, and those need to render inside the web components, and they need to have a very native communication bridge where the parent and the child can share context and this and that. And combine that with performance overheads and take it even one step further, realizing that modern frameworks these days are trying to improve performance by doing as much work as possible before you get to the browser, right? Like React Server Components is trying to create all the VDOM outside of the browser and just send the VDOM to the browser. Or Quick is trying to create all the HTML in a fully resumable state and just send the final HTML to the browser. The idea moving forward we're seeing is people trying to avoid that browser main thread. Browser main thread is the results, not the orchestrator. And so all this stuff started falling apart in our hands. Web components was quickly becoming the worst of all worlds for our use case, at least. I will say we still use web components occasionally. Like if you just want to have a simple widget you can embed on sites and server-side rendering is not critical, works fine. Very simple, much better than like, window dot, doing things in a very jQuery-esque fashion. So there's still a use case that I've seen can work nicely. But it turned out for us to not be that one size fits all components everywhere. And, I know Mishko does too, have concerns when we see people acting like web components are or could be that, given some of the approach and trade-offs and this idea that, there's not a shared rendering system. So you could install 20 web components and under the hood, they're using Preact, React, Vue. I mean, it can get bloated. And so ultimately we came back to what we need in theory is first-class SDKs. The React SDK for Builder needs to function just like it was handwritten for React. That's how you provide the optimal developer experience, compatibility, performance optimization, right? At the end of the day, these things should really be something that feels just like it was hand-coded for you. And so then we step back and we're like, hey, what's kind of funny is Builder in itself, when you create sort of pages, documents, et cetera, in Builder, you're really just making a JSON representation of a page. It's just JSON that says, put your hero here with these props and put your products here with these props. It can render elements, and it can also, as JSON, show like where the binding should be. There should be a binding to, product.name and stuff like that. And we were like, in theory, we could just compile that JSON to React components, Vue, etc. And we had experiments doing that. And we kept thinking further, like, okay, that's cool. Maybe we can take JSON and produce first-class React components in Vue, and those become these SDKs. But then you run into the issue that JSON is just not fun to code in. You won't get type checking. It's not very easy to look at, right? It's not human-friendly for building complicated things. It's like strings and stuff. And so the next question was like, well, can we add a JSX syntax that just kind of is one-to-one with the JSON? So JSX has a structured way of saying elements, properties, bindings, children, etc. Could we do that for some separate thing that you could write a component as JSX, which we chose because we didn't want to invent yet another templating system. And JSX is shared across several relatively popular frameworks. So we went with that, and the TypeScript tooling and support is great. We didn't want to reinvent that. It needed to have a couple of tighter rules. You can't just write expressions everywhere. So it has to be a subset of what all the common frameworks provide, or things we can generate little code snippets to provide compatibility with. And that's how we landed on Mitosis. So let me do a quick demo, and then we can talk about some more specific stuff here. I want to do a brief screen share. We can show some stuff. Okay. We're probably going to have the crazy matrix effect. Okay. So here's two things that I think are kind of cool. This is our Mitosis fiddle at mitosis.builder.io. This lets you write code. So I'm just going to change this to, I am Sammy. Padding.
I'm going to jump in here. You need to make the font bigger, sir.
Oh, yes. Thank you. Let's be more friendly to different size screens. Oh,
I'm glad I provided value.
Yes, thank you. And I think, this is a good sharing mode. Cool. Does that look better? Let me take that as a yes. So we can go in and just edit this code.
You could go one more.
Go a little bit bigger?
Yeah.
There we go. I've got some code. So as I'm coding, let me show you what's going on. So we very much went React style. So hooks, we have a thing called use store, JSX, bindings, event handlers, right? The normal stuff. They can delete and change and modify and whatever you want. And you'll see it doing two things. One is it's compiling to Vue. And the rule of thumb here is we try and be as idiomatic as possible, meaning the rule of thumb is write or generate code just like a developer would have written by hand, or as close as humanly possible. So this is not trying to be like a Babel output where it's not really human readable. It's not very elegant. This is trying to be very ejection friendly. And this is a good rule of thumb, because if you want to have good performance, write code like the framework authors intended, and then the various tooling and framework optimization should kick in. So we've got React, and we've got Quick and Angular and all this stuff. Svelte is a pretty funny experimental one. I think I said Swift. Svelte is here. React Native is a really cool one, actually. And you'll see just a ton here. One that I'm excited about is Marco, because Marco is, the native ones are interesting because it's native. Marco is interesting because it's MPA first. So this is writing essentially a backend application first that adds client-side goodness only when needed. Lit is cool because it is web components. So this is kind of to that point of, do you want web components or do you want Mitosis? It's like, well, Mitosis is an output at web components and various different frameworks, Stencil, Lit, or just raw web component code. So this is cool, but what's interesting here is Mitosis really is just JSON. So JSON that describes the state, and JSON that describes the elements and the styles and stuff like that, which means we can also interoperate with like a no-code tool like Builder, which I think this is neat. I can make updates here, whatever I want. Like I'm increasing that padding, hit save, and you'll see down here we made an update. Somewhere in here, my padding update took hold. But what's cool is the last thing I want to demo, and then we'll talk about the details here, is here is a different application we made. It's a way to benchmark different frameworks against each other, like LCP, TTI, these common lighthouse metrics. And what's neat is I actually have it running a bunch of servers at once, all with code generated by Mitosis. So we have a simple to-do app where we can add our to-dos, modify them, clear them, etc. And you can see, like with this Next.js example, we can go into the React component inspector, and you can see us filling in to-do items. So this is all first-class React components. We can switch over to something like Nuxt, and the same exact thing takes effect. We should be able to open Views Dev Tools, and get in here, and there we go. So to do items, cross out, clear done, etc. You'll see it all is first class view code, and that goes with everything. Marco lit, everything down here. I'll save you all from being bored, and then we can do cool benchmarks across them to see which one is faster across different metrics. But let me stop my screen share and let's rope it back in, and I can stop rambling, and we can go a little bit deeper on questions that come up and sort of topics. So let me use this as a point first to say, okay, mitosis versus web components, when you should choose each. Mishko, finally getting to you. Apologize for this long delay. So you explored web components for the Angular framework as, I think, a first-class thing. Like, as you went deep on web components and said, hey, should this be a critical part of the Angular framework or frameworks? Like, what do you think about this topic? What were your learnings? Tell us everything.
Tell us everything of years of experience. Yeah, so when we originally started with AngularJS, right, and there was this switch where we did Angular 2, which eventually we just renamed it to Angular. And we spent a lot of time looking in web components because the idea behind Angular was, or rather Angular 2, right, was that we wanted to be as standard compliant as possible, and web components was kind of the thing. And we had kind of prototypes up and running with it, but we kind of very quickly realized it's not so simple. I think the short of it is that, frameworks provide a lot of facilities for yourself, right? It's a component model, it's templating model, it's intercommunication model, it's communication model, state changes, etc. There is a lot to what a framework is, and styling to be among other things, right? And when you come to web components is kind of a fancy term, but really it's just two things, right? It's custom element and it's shadow root. Everything else is just not covered inside of web components. And those two things are a small portion of overall what a web component, of what a framework needs or what an application needs, right? So yes, you need a way of like having your elements, and you need a way to encapsulate things, which is what shadow root is. But there's a lot more to what a framework is. And so a web component is not really a replacement in that sense. It can't do many things that you want. One of the things that a framework provides is an orchestration layer, right? It basically says, oh, it's time to render. And then goes and tells all the components to do the rendering. And then it updates the UI all in a single thing. So that everything is synchronous. Everything happens together. One problem with web components is, for example, that, well, they all kind of decide to render whenever they feel like rendering because, well, rendering is not fundamentally defined in their lifecycle hooks, right? And so people just like do rendering whenever. And so that creates a bunch of problems. First of all, the user will see intermediary values. And also, there is no easy way to kind of make synchronization between these components. And people say, well, that's not a big deal. You can like add extra code. And the answer is yes, you can. But now you are building a framework, right? And maybe that you shouldn't be in the business of that. That's one thing. And the second problem is like, well, it's easy to add if you own all the components, right? The promise of components is this idea that you could just like go and like grab, I need a chart component. So I'm going to grab a chart web component. I need a input box component with tiles, and I'll grab one of those, right? And you just put it in. And now the thing, you're in the situation where you don't own the source code, right? And so you don't know what strategy the chart component has chosen for rendering, and you don't know what strategy has the input one chosen for the rendering. And of course, you are probably writing it in yet another strategy. And now you have three competing things that are all trying to update the DOM. And it kind of works most of the time, except it doesn't when you come to the case of like server-side rendering, or if you wanted to coordinate all the reads and all the writes, making sure that everybody does the reading and writing to DOM all at the same time. And so this is where it kind of breaks down, right? And there is a need, and I apologize if I'm going on a diatribe here, stop me. There is a need for this interoperability, right? Like there is a need for saying like, I'm kind of tired of writing the same component over and over again. Like I'm tired of writing the chart component for Angular, for React, for Vue, for Quick, so on and so forth, right? It's tiring and it's annoying. And so there is a need for it to have a way of sharing these things. And I think this is definitely a direction as an industry we should go. But I don't necessarily think that the answer is to do it at runtime level, right? You have several choices. You can have the one extreme is do it at runtime, which is what web components are. And the other extreme is to do it at compile time, which is what mitosis is. And of course, you could have something in between. Like, for example, I can envision a component that could be written in a way where it, like at runtime, like detects like where it's running in, and based on that, it presents different API to the outside world. Like you could do that, like you could do it all in runtime, and that's kind of sense away, right? And so there's different choices we have, and you know, we kind of decided that web components are the thing as an industry, and I'm saying like, it's not so simple. Like, back up a second. Like, there are other choices, and these other choices actually might be beneficial. And I think what I like about Mitosis approach is that you end up syncing on the behavior, right? Like, you create a new component, and the component participates in all of the rules that the framework that it happens to be running in has decided that are important rules and you should participate in, right? So whether it's communication of data, whether it's deciding when to render, whether it's making sure that the rendering happens at the right time, there is value in participating in all that stuff. And I'm going to shut up now, and I'm going to hand it off to maybe Sammy. Sammy might have opinions as well.
One thing, I mean, so for those listening, I don't have as much experience, whether good or bad, with web components as Steve and Mishka do. It sounds like they've had to toil away and deal with this for a while. But one thing that I found interesting is every time somebody comes in asking or trying to understand mitosis, they're coming from that world where web components was the promised answer. And so they always come in and be like, oh, well, you know, like I'm worried about how event handling is going to work, and how event handling comes up a lot. I don't know why. It must be a pain point in web components or something. But then from my perspective, as somebody who's just been maintaining mitosis, I'm like, this is a non-issue. There are so many things that people come in they're worried that mitosis might not be able to handle. And there's that moment when it clicks, when they're like, oh, literally all mitosis does is it writes a string that's my component, and it writes it the way your like average, just like well-intentioned React, Vue 2, Vue 3, svelte, quick, solid JS developer is expected to write a component. They're gonna take all their CSS, they're gonna put it in the right place, they're gonna write some JSX, they're gonna write their state, their events, they have set data in the right way, and then that's it. It's just a string. It's just a string, and there's zero magic. And I think that's the moment when things click, and then when people finally like realize like, oh, so this is like, there's nothing crazy that's going to happen. There's no magic that's going to go on. There's nothing I'm going to have to wrap my head around, which from the sound of it, and correct me if I'm wrong, like there is, when you set up web components, like it's only the beginning, and you have to like wrap your head around how it's going to work with every single framework. Whereas with Mitosis, you just like write this thing that's kind of like a combination of how you do things in a lot of different frameworks, and then it spits out just pure components. There's nothing else. Mitosis will never show up in your end result. No one will be able to ever tell that by inspecting the DOM, by inspecting your source code, that your code was ever built with Mitosis. It will look like a human being wrote it. And I think that's the like really fascinating part, because it also adds like this kind of auto eject aspect. So it's like you're not bound by anything you're doing with Mitosis. If at any point you're like, my component just got so complicated, I would rather maintain two different versions, one for Angular, one for React. You already have an Angular file and a React file. You can just stop generating it and start just committing those outputs to your GitHub and repo, and start editing those by hand if you want. So yeah, I think that part is really, really big, and it's something that seems, I guess, to be missing from the web components approach.
Can I jump in? Okay. So first of all, yes, what you said is totally on. And I'm just going to reiterate basically exactly what you said, which is that there is no runtime component to Mitosis, right? When Mitosis is done, Mitosis silently disappears from your code base. And as you pointed out, like there's nothing in there that could possibly tell you that this was generated by Mitosis, right? It's just the code that you have written. I just kind of realized that I kind of pointed out kind of the shortcomings of web components. And I think it'd be useful to also point out shortcomings of Mitosis, just to kind of have it more balanced, right? So it doesn't sound like I hate web components and I love Mitosis and I think it's the answer to everything. You know, there's always trade-offs with whatever technology you happen to choose. And it's kind of important to understand the trade-offs. And it's kind of, like you really understand the technology when you can talk about the trade-offs between them, right? So the thing to understand about mitosis is you write, basically mitosis is yet another way of describing your intention to the world, right? Like we have our own syntax, which doesn't really run, but it's just a way of describing it. And the syntax we have is, in a way, the least common denominator between all of the different frameworks, right? All frameworks have a way of declaring a component. All frameworks have a way of declaring a template. All frameworks have a way of declaring a binding, and so on and so forth, right? And so we looked at all of it and said, like, well, can we have some syntax that kind of covers that all? And when you do that, you're unintentionally take up a certain burden. And the burden is that while syntactically you can match the output of all of the outputs, semantically, you might have surprises. For example, there is a piece of code that you might say like, oh, I want to run this piece of code on initialization of the component, right? And different frameworks might interpret that in a different way. So some might, for example, say like, oh, well, I will guarantee you that this code will run before I render the component. Other frameworks might say like, oh, if this code has a promise in it, then whenever the promise finishes, it will finish. And therefore, there's no guarantee that the framework rendering will actually wait on the output, right? So because of that, there are semantic differences in the behavior of the outputted code. And at times, you actually will have like strange behavior, like, oh, I wrote a code that I would expect it if it worked, and it works in like everywhere except for like whatever, Angular, because Angular semantics are slightly different than everybody else, or the order of things are slightly different, or something like that. And so you end up putting, from time to time, you end up having to deal with these kind of differences. But overall, I still think that this is not really that big of a deal, and it's just something to be aware of. And I'm actually very familiar with this particular problem because if we go back in time, there was a time when Angular actually produced both TypeScript output and Dart output. And in a way, it's exactly what mitosis is, right? You wrote code in one syntax, and then we had a transpiler, which wasn't called mitosis, but for all practical purposes might have been, which converted the code over to Dart. And most of the conversions were 101, but syntactically, they were never 101, right? So for example, if I say A plus B, you think that everybody agrees on what the meaning of A plus B is. And for the most part, yes, we do. If A is a number and B is a number, then of course, the answer is you add the two numbers together. But what if one of them isn't a number? Like if one is a string and the other one is not a number, well, JavaScript will convert the other one to a string and then try to add it together, right? Dart will throw an error. Other language might do something else. For example, what if A is an array and B is an array? Like, does the plus mean to concatenate the arrays? Well, that's specific to a language, and it's basically at the level where these transpiler tools have no opinions. And this is what I mean by the semantic mismatch of the thing. And this is what mitosis does not do. Anyways, I think I went a roundabout way to basically saying, no solution is an answer to everything. But it's a different set of trade-offs. And the different set of trade-offs basically is that I think there is value to having to deal with these semantic mismatches during compile time rather than having to deal with these things in runtime. Because runtime is performance impact, whereas compile time is like, well, your build is whatever, slower or whatever, right? It's not something that actually translates to the end users. And so there is a lot of value to be gained by having your application in one consistent framework runtime model or implementation model or whatever. Like the stack traces are more sane, the execution model is more sane. You don't have weird updates or rendering times where you don't expect. Everything just works in a consistent manner. Okay, I'll stop.
Yeah, no, and that's why it's worth adding. I think Sammy wants to say something. I'll add a couple of things, and Sammy, you jump in. The way we deal with that exactly like you said. One is compile time tricks, like insert this in a slightly different or unexpected place in one of the frameworks because of what the expectation of the author is. Or more frequently, we just add restrictions. So I think the biggest trade-off for mitosis mostly is the restrictiveness. It has pros and cons. The con is, there's kind of one way to do things. And there might be some advanced feature of a framework. It's like, you might not get it. You're going to have to stick to that lowest common denominator. Now, in my opinion, the lowest common denominator of frameworks is pretty simple. And there was a time where I wasn't sure how complicated of applications you can build just with these things, just with elements, components, props, bindings, lifecycle hooks, state. You have those 6 or so things only, and you don't have anything else magic on top of that. What can you build? Turns out you can kind of build anything. But yeah, and one of the questions we had here is this stable enough in production? It's in beta, and beta to us essentially means like there are no known huge issues, but you may discover some that we have yet to discover. I would say with some projects like Quick that'll be in beta soon, I think people won't hit a ton, but they will hit some. With Mitosis, I think there's still lots to be hit. And so I do think beta will last a decent amount of time. The people who should probably use Mitosis are people who it solves a serious problem for. Like, I love the ultimate end goal that could potentially be achieved, where you can really have one way to just write a component that is future proof, or at the time of authoring your component, you don't have to ask yourself, oh, I need to choose X framework because I want to be optimized for TTI versus LCP versus render speed. You don't have to make those choices at the time of authoring. You just build your stuff, and then you can generate out a quick application if you want insane fast load time. Or maybe you love SolidJS for its insane re-render performance. You can make those decisions later without rewriting applications, because many of us have been through that experience of, you had this really heavyweight backbone application and you just need it to be faster and more elegant. So you rewrite the whole thing in another framework. And then the next framework is popular and you're like, oh, when do we rewrite to that? It's like, well, can we end that? But the counter to that, well, the last thing I'll say on that is, so there's basically one way to write a function in Mitosis that's part of the components, like needs to be utilized within the template or whatever. There's not a variety of ways. That comes with the downsides of, oh, maybe some frameworks have nice nuances for certain use cases, Mitosis might not. It comes with another funny benefit though, which, there are times where I write Mitosis components and I'm like, this is some of the more elegant code I've written recently, just because it forces you to do everything one way. And it's kind of nice, and why I hear some people really like the Go language and stuff like that. But I would definitely say it's most likely not worth using unless you actually have that use case of, it's either Mitosis and dealing with it still being early and needing to create issues, contribute this and that. If it's that versus actually you have to write a complex project multiple times for multiple frameworks because you're a large company that supports, you need to make one design system that works across all your applications, which are like React, Vue, Angular, which we see, or you create an open source project or an SDK of some kind like Builder or certain UI frameworks. God, I can't remember if I'm allowed to name one of them. I won't, just in case I'm not allowed to. But one pretty significant one is rewriting Mitosis because they currently only support one popular framework and they need to support others, and they need to be able to manage this. And so I think if you have the right use case, it can be an amazing fit. But if you're like just making a personal site, probably just pick your framework, because I think the biggest thing that framework authors will say about Mitosis that they don't like is you can't get the best of that framework out of it, right? So like Ryan Carniota will say, you will not get the best, most optimized deep granularity out of Mitosis most likely. And that's most likely right? We're going to generate idiomatic, but arguably generic code for certain use cases, whereas a developer handwriting for that framework could have gone a level deeper, a level more performant. So it's another reason why this is maybe best for things like, UI components, simple ones, libraries that provide that, and less like your entire application, so to speak. It's maybe worth adding briefly too that there's still some great use cases for web components, right? We use it for certain things. I'll be honest, if I just want to be lazy and just provide not necessarily the best performance, but a very compatible way to load a component, like we have a way to embed our builder fiddles. We use web components for it. It's awesome. It's just a tag and a script. Anywhere the tag exists, you will get the contents of what you expect there in a consistent way. That could be fantastic for certain things, but with the caveats of it's not going to server-side render. It's not going to necessarily be the best for performance. So performance, I think we'll circle back in a minute, because I think one of the most confusing and controversial topics about web components is performance. There's, advocates of web components talk about the performance is great because it's browser native. Yet we worry and have seen in practice, there are certain other sides of that coin too. But Sammy, I think you had something. I hope I didn't tangent way too far because you unmuted, and I think you had something to say on an earlier point too.
I have like 10 things I've written down that I can comment
Go
on.
for it.
Regarding what we can say about who's using it, I think that person commented on the Twitter thread about this talk. So yeah, so just to go over like the 3 categories that we've identified of people and like teams or individuals who can benefit from mitosis, and I think we have an example of each right now being built and or being used. The first one is, and there might be different use cases that we might understand better in the future, but so far, one of them is you're like a large tech company or large company with a lot of web teams, and you're trying to maintain a cohesive design system across different web applications that are not written in the same web framework. So this is like an internal design system, and that we cannot name right now, but once they launch, maybe we can. But we have some enterprise folks that are building with Mitosis that are like, this solves that problem for us. We can output to multiple different frameworks, and the designers can just kind of sit there and be like, okay, this is it. This is what it looks like. Okay, ship it to all these different web apps. The other example is, so open source software, UI systems. So still kind of like design systems, but open source ones. And that's one that I find really interesting because it's almost kind of sad that you would look at, like, you'd find this beautiful autocomplete React component and you'd use it while you're a React developer. And then you'd move on to another web framework, or you just think of all of these other web applications, all of these other people using other web frameworks, and they don't get to benefit from this like perfectly good, at the end of the day, JavaScript code that, frankly, if we're all being honest, has nothing to do with React. There's nothing special about React that make that React-autocomplete NPM package work. And I'm just using that as an example, just like the first one that pops into my head. It's a component that I've used in the past, but there's like every single framework has all of this tooling, all of this ecosystem. And for, I think, 95% of these scenarios, it makes no sense that they're siloed to one framework. We're duplicating so much work across our industry, whereas we could pretty much like just all work together towards the best autocomplete component, the best UI design system, the best modal, the best like hover interactions on the button. There's like all of these problems that we keep having to resolve for every new web framework, but there's nothing special really about most of these frameworks. They're all like, yeah, we've kind of all implicitly converged in all frameworks to be like, well, you need some code that's going to run when your component shows up. You're going to need to do some cleanup code when the component gets taken out of the DOM. Oh, when the component's going to be able to receive properties, and if those properties change, you would like to rerun some code that depends on these properties. Oh, and it needs to have some like local state that's tied to this component, and there needs to be some context. I just described like, I don't know what the percentage is, but that's like 80% of the web developer's day-to-day life. Like there's some edge cases. It gets more complicated sometimes, but like what large percentage of web components in the wild did I just describe? Like that's all it is. And every framework can do all of these things. And it's just a question of writing them slightly differently. Like Vue says you have to use this watched and computed thing. And then React has use state and use memo. And it's all just small semantics. It's just write this thing instead of that thing, and then put the exact same JavaScript code inside of this function. And so, yeah, I think that's like one of the most exciting things about Mitosis is that you have these, you could have this consolidation. If Mitosis will, I'm hoping, like will keep on building up this momentum, in 5 years, you're going to start seeing like a lot of design systems written in Mitosis, which means that every web framework user will have access to like all of this pool of really well-designed, beautiful design systems, which is really great. And to get back to your thought, the design system that is currently looking into building with Mitosis is the Vue storefront UI. So yeah, I think the CEO commented on Twitter, so I think that means it's okay. He said, yeah, they've been using it and they've been loving it. And so they're just going ham, like rebuilding and their like components that are currently just in Vue to be in Mitosis, which means it's just going to work across like 5-10 frameworks instead of just one.
Can I butt in on a brief point on that one?
Yeah.
Just the one thing that's cool, and then happy to kick back to you if you got more stuff you want to sort of throw in. But what's cool about that to me is, I've been watching the adoption of Solid.js, for quite some time. Ryan made an incredible framework, truly fast, flexible, beautiful, efficient. Like, in my opinion, it's better than React in every single way, objectively. I guess it's impossible to say truly objective for these things, but it's just better. And the problem is, you can't just migrate to a better framework because there's no ecosystem yet. There's not all these, like you said, all these libraries. There is no Solid.js storefronts. There is no Solid.js autocomplete. There's none of this stuff. And it's crazy to see someone put so much time into making something that it seems like virtually everyone who tries both says, oh, this other one's better, but the adoption is not nearly at the tirade that React is, given that huge ecosystem. I'm extremely excited, or we make Quick, and I'm so excited to get storefront UI for Quick and Quick storefront, not just to make sure people can just rock and roll with Quick with just a killer sort of set of front end components, because that really inhibits framework innovation if there really is no real third party anything that can work natively with that framework. And I'm excited to benchmark. I really can't wait to do Vue Storefront for how does it benchmark across the different frameworks. So anyway, I just want to throw that in. And Sam, if you got to add, please go for it.
Yeah. No, I mean, I fully agree. And I think, for us, we're probably we're feeling that pain. We've built Quick, and we're trying to drum up, we think there's value in it. And now we're like, oh, we just need like this vibrant ecosystem of a ton of open source components that people can use. And almost like Mitosis could theoretically promise a separation of these two concerns of like, let's leave all of this fancy schmancy, like DOM interaction, like serialization, resumability, SSR, all this crap. That's okay. That's a web framework's job. But then like authoring web components and like having them be reusable and just have that rich ecosystem, that should be framework agnostic. That should not be tied to the fact that this one component supports SSR. Like these are completely separate concerns. And they might have not been very early on, but I feel like the reason Mitosis works is because we've been converging to this common understanding, like we've said a few times already, is common understanding of what is a component, what is a front-end component. And we've agreed that like you need to be able to give it props, it needs to have state, it needs to be able to re-render certain JavaScript code depending on other things, like it needs to be able to react to changes of things. And there's like 5 or 6 or 7 of these features, and Mitosis is kind of built on kind of this implicit understanding amongst the people who created Vue and Svelte and React and Quick and Solid.js, et cetera, that like our framework needs to be able to do most of these things. And so that's how this Mitosis JSON, this intermediate representation works. It's just like it codifies this notion that like this code, this string of JavaScript code needs to run when something mounts, updates, unmounts, on initialization, et cetera, and the fact that most web frameworks kind of support all of these things is what makes it work. And I mean, unfortunately, or maybe fortunately, it would have been tedious to have like every framework author sit down on a big round table and agree. I guess that's kind of like what web components try to do. But we've kind of just said like, yeah, we're all kind of converging here. It's just kind of like small details of how internally frameworks do things for performance. But authoring a component is a similar experience for most frameworks, for most scenarios. And that's why Mitosis is like able to even exist, I think. The third thing I wanted to say, just to go back to like the uses of Mitosis, the third case is SDKs. And it kind of ties into the question somebody had in the comments around it not being ready for whether it's stable to use in production. Like our SDKs are like, Mitosis is in beta and our SDKs built on Mitosis are in beta, but like we have serious enterprise customers at Builder using our Builder SDKs that are built in Mitosis. So like we have a decent amount of confidence in it, and we're sorting out kinks as they come, but like it's not this thing that's just sitting in a vacuum. It's something that's being used by websites that have a lot of page views right now across the world. So like there's a lot of it that is stable, but it's like in beta, I guess, until we have like some more data points or more confidence and iron out some more core V1 features.
Yeah, there are huge websites and apps that everybody here probably uses every day that are powered by Mitosis components. Anyway, Mishka, you want to add something?
Yeah, I was just like gonna reiterate what Sammy added to it, is that I'm super excited about the Quick SDK, right? Like we didn't have an SDK for Quick for Builder, and then we just added Quick to Mitosis, and all of a sudden the whole freaking SDK is there, and it worked. Like, of course, there was issues to kind of iron out at the very, very beginning, but like all of a sudden you have a full-fledged SDK that has parity with all the other ones, and it's kind of mind-blowing. It's super exciting. The other thing that I'm really excited about is, I think Steve, you kind of pointed out, like it is unfair that there is so much inertia with the frameworks. Even though there's better solutions out there, people aren't able to switch because, well, we don't have component libraries to go with it. And I think the market has already spoken that, web components are kind of a okay hack, but not really what people want, right? Like otherwise, like this would really, really take off, and it hasn't. So like, I think that kind of speaks to the situation, what it is. And so having component libraries be written in Mitosis, and there's some work that's already happening in the space, kind of democratizes it, right? Like it basically says like, now you get to choose your framework based on the merits of the frameworks rather than for historical reasons because whatever, right? Like, there's no worse answer to an engineer than like, well, you're correct, but history, and you have to use this other thing, right? And so I'm super excited about that. Like, I think having a good set of widget libraries in these frameworks really will enable more frameworks to kind of flourish. And I know people are going to come and it's like, why stop with making of the new frameworks? Like, it's just a form of innovation, right? Like should we stop designing cars or cell phones, etc.? Like, isn't it great that like every year new better phone or car or whatever comes out? Like, it's the same thing with frameworks, right? We're just learning and getting better. And so like you want to encourage this innovation rather than create ways to kind of prevent it.
Yeah, that would be great too. Like if we get to a place where we have these design systems, and we have like one example, which I don't know if I'm pronouncing correctly, like papanasi.org. It's like, so there's somebody building a UI design system in Mitosis, and the idea that you could get, like, if you were to just have one design system in Mitosis, you can suddenly say like, whoever is about to create a web framework now, is, as long as they just make the effort of like also building the generator in Mitosis, they now have this design system ready to go. So they can tell anybody, hey, use my web framework and you have this 50 component design system that somebody else built, and it works. And you can get started. You don't have to just do so much work from scratch. So it really democratizes this access. And we could end up in like, I mean, that's maybe long-term vision, I don't know, but like, if you end up in this world where like there are constantly new web frameworks, but it doesn't feel like this JS fatigue, because it's just like, oh, people are trying different things, and they can always tap into this rich ecosystem, which should be like, the web is this open thing. It's all just JavaScript code. So it makes no sense that we're like reinventing the wheel for every single web framework, reinventing things, recreating. Even like the people that are working like Chakra UI, they're like, the author was talking about the pain of building it for React and then Vue. And then that is just unfortunate that like somebody's working so hard to do the same thing over and over again, which is what all software developers hate. And he came up with a solution that's more about the UX interactions with finite state machines, but probably still has to do a bunch of like manual work of setting elements and stuff, which Mitosis can hopefully alleviate the pain of.
Yeah, that's actually, so we've got one question I want to address in the audience, and then I want to circle back on that one, because we're seeing that other trend, headless UI components, like the TAN-stack libraries as well, which, so we'll come back to that one, because that's also relevant to this that Ryan had previously pointed out. But let's go to this one. The same question cropped up a couple times, basically asking, can we cross-compile? Can we compile from one framework to another? This is the number one request we get, and this is number one where I spend too many nights thinking about how to make this happen, because the problem is, or the challenge is, Mitosis needs a consistent structure. It actually, I mean, so here's the thing. Mitosis works just like LLVM, the LLVM toolchain for compiling like Swift to the LLVM intermediate representation down to all the different sort of hardware architectures, or maybe I'm not using the proper word for that. So that's why we have C, C++, a bunch of other languages can work nicely on all sorts of different, hardware types that you want to use those languages on, and the developer doesn't have to think about it. And so it does that by creating an intermediate representation. As long as you can compile any language, they call it a front end, to the intermediate representation, we can take the intermediate representation, optimize it, and generate down to all the different, even lower level formats that are needed to run on today's machines. And LLVM does an amazing job at that. I mean, I think it's a good example of the biggest pro and con to compilers is you can make them infinitely complex. So you can make them infinitely optimized, detect infinite situations to make all sorts of things. Another comment came up here, which is that there are cases where a compiler can generate better code than a developer. And if we're kind of understanding that developer means an average developer, which has various degrees of expertise in various areas of performance, yeah, sometimes the compiler can be built to know certain things that the average developer might not always have top of mind, or might find too tedious and everybody gets lazy, right? And automating is pretty amazing. But the big question is, and so the reality is, just like LLVM, we can make as many front ends to Mitosis as we want. So currently there's 2 supported front ends. There's what we call JSX Lite. It used to be the name of the project, a subset of JSX that can compile to the Mitosis intermediate representation, which we just call like the JSON format because it's just human readable JSON. The other front end that's officially supported, kind of also beta, is Builder, the Builder visual editor to Mitosis. So that means with Builder, you can drag and drop or take templates or import from Figma and turn that into high quality, relatively idiomatic code for all your various frameworks. So if you want design to code, you have it there. Now, the next question is, can we pull in, like the real question here, can I just convert a React component to the Mitosis JSON? The answer is no today. We can do subsets though. So the Marco team is actually looking at potentially taking Marco and compiling to Mitosis. So Marco components can actually run, on React Native or whatever they're looking for specifically. Marco is a good example because it's a very declarative format. So a subset of Marco should very elegantly actually be able to convert to the Mitosis JSON, if not the entirety of it. Svelte is also another good one that's more kind of structured and compiler oriented that I think we could have a Svelte Lite. I mean, we've done various experiments to have a Svelte Lite, a Vue Lite, an Angular Lite that can compile nicely to Mitosis. And, you could make it so that obviously if it's a subset of those frameworks, they also work, just with the framework too. So certain Vue components, if they're using maybe, .lite.vue or something, and there's a few added rules maybe enforced by ESLint, they can work both just normal as Vue components and to Mitosis. And, the evolution of the Mitosis JSX syntax is a bit interesting too, because for the longest time, I wasn't sure JSX would be able to do this or any other templating system until I saw Solid.js and how Solid.js used structural components for like loops, the for component, or for conditions like the show component. And that was the big unlock to make it clear that Mitosis was possible. But what's funny is since then, both Solid.js and Mitosis have implemented turning things like ternary operators and Boolean expressions into the show components and the for components. So that structure, we're able to understand certain just straight up JavaScript expressions and conform it. So the big question is how deep can we go down that rabbit hole with React hooks being relatively structured? Is there maybe a day where a good amount of React components or Vue components, Vue has a kind of more structure in a certain sense, could compile Mitosis? Maybe. The more we just think through what are patterns people do and how does that transform to what Mitosis expects, it's a big maybe. But if anybody wants to send PRs or contribute or share ideas, we'd love to keep discussing this one because I think it's fascinating. And yeah, I mean, if you can compile one framework to another, that would wildly unlock ecosystem benefits for, if you could have every React library in Solid.js and Quick, wow, that'd be huge. We're not there today, but I'm not sure we can be there ever, but, TBD. I do want to get to one other thing that Sammy started to bring up, which is headless UI components. So this one's interesting, and I have an opinion on it and see if anybody else here does, but to me, they provide some very useful utilities, which I think is great. And there's things like, I think it's React Aria that it only supports one front end, but it still is headless in a certain way. It's mostly just JavaScripts that you run and you plug into UIs as you choose. My gut reaction to them is I just want components. I just want to have my something component, stitch them together. I don't want to have to mentally think about all the mappings and all the utility functions and how it turns into UI and stuff. Now, I haven't used these in depth, so I could be naive here, and it might be one of those things where to use it, you have an aha moment and you realize it's great. But my gut reaction is it's born out of necessity. Because we can't do components, then you're forced to have componentless logic that you plug into components. And so it's just a set of trade-offs. Which is part of why I like the compiler approach, because we're not kind of like handcuffed to a runtime specifically, and it's part of why I think web components has to be a pure runtime thing, right? There's days where I think that web components there would be no controversy about web components if we just didn't call them web components. If we just called them Shadow DOM and custom elements, there'd be no controversy because there's no implication that it's replacing something else or it's an alternative to a React or Quick or whatever. And we can embrace the fact that component-based frameworks are moving a certain direction that web components or custom elements just do something different. They're dependent on the browser main thread, but Quick, Marco, React Server components are trying to get away from the main thread. And that might be the future. We think it is, but we'll find out. And so anyway, I said a lot of things. We have 5 minutes left. We can go through a couple more questions unless Mishko, Sammy, there's anything I touched on there that you'd love to jump in on some thoughts on.
Mishko, I was rambling for a while right before Steve, so
No, I'm good.
Well, I have a
You
question. I
always
have
make
one.
me ramble, but
I do have one question specific for you, Mishko. Can you answer us the question? This was the most confusing thing to me. I think I had my head wrapped around it, but I'm curious what you think. There's some. My impression of web components is not positive for performance for the reasons you said. You're stitching together various things with have their own dependencies, their own way of rendering. And we've learned with frameworks that the more you have consistency, the more you kind of share dependencies, the more everything is orchestrated properly, you get lots of benefits. And the idea of client-side JavaScript, main thread JavaScript, all these things we're trying to get away from with Quick and other modern sort of framework directions that others are doing. But there are others out there who are like saying that web components are the best thing for performance. It puzzled me. I think I understand what they're saying. What is your take on this? Why do some people passionately think web components are better for performance, and why do we kind of have a different opinion?
Yeah, it's interesting, right? Like when people are passionate about something, clearly they have certain understanding, or they understand something that either you don't, or you understand something that they don't, right? Like there is definitely a difference in understanding. I think a lot of it is that, if you look at super, not the best use, for example, like React will re-render the whole thing, but only if you like do everything kind of, I don't want to say badly, but like if you don't do extra work, right, then it's the default behavior. And I can see in that world how like a web component might be a better answer. But then like, of course, the React crowd will say like, yeah, but like we have all these escape hatches, like just use one of those things. So I'm not actually sure why people have that opinion. I mean, a lot of benefits in terms of performance come from this idea of like, if I can just assume that you will follow rules and you will not do certain things, right? If you can make that assumption, then I can simplify my job as a framework, or other, not necessarily simplify because I'm lazy, but I can be more efficient, right? But you must promise not to break these rules, right? And so React did that. React basically says like, oh, everything has to be immutable. And then if you follow those rules, then like we can do all these things. The problem I have with web components is there are no rules. Like it's a free for all, right? Like web components don't specify like, oh, you should do this or that or whatever. And as a result, there are very limited kind of optimization tricks that you could do on kind of the application level, right? Because nobody has defined those set of rules. So yeah, I don't actually fully understand that point of view of people of like, oh, just switch to web components, everything's going to be faster, better, and whatever. Like I don't see how that naturally follows, right? Like if you're going to make an argument that something is faster, really, you can make it out two ways, right? You can say like, oh, I have to do the same stuff that you do, but I can do it more efficiently because something, right? Or you could say like, oh, I actually get to skip a whole bunch of work because there are certain rules that we both agree on, right? And I think a lot of performance benefits that really is coming in, it's both micro optimization and macro optimization, right? A lot of things you can get by getting better at micro optimization, but there's a limit to it. Whereas what really is winning, I think, is this macro optimization level, right? Like Quick is unbelievably fast on startup because it says like, well, please follow this set of rules. And if you follow these set of rules, then as a framework, I get to do certain shortcuts. And these shortcuts will be then given back to you in terms of performance, right? But it only works because there's this implicit agreement. In other words, the framework sets up a mental model that you as a developer agree to follow. And in exchange, you will get a certain level of performance that is that you can't get somewhere else, right? And to me, like that's kind of the problem with web components is they don't have these set of rules. They basically says do anything you want, and the moment you do that, you, in my opinion, you can't be as performant as other systems that have these set of rules.
Yeah, exactly. I mean, the trend of the rules is to do as much work as possible before you get to the browser and as little in the browser as possible. And web components are standard to do everything in the browser. And we're like, that's kind of the issue. I see that one of the big arguments I see for the benefits of web components is, typically going to a browser native path for something is a good idea, right? The browser native way to do X is usually the better way, right?
I will argue actually the opposite. I will argue that there are situations where doing the browser way is absolutely the right thing.
Yeah.
But like there are situations where it's not necessarily obvious, right? So my rule of thumb is like if there's something that only a browser can do, like for example, if you want to know what location it is, well, clearly a browser has to add that API because there's no, I mean, you could do some horrible guesses, right? But like fundamentally, unless browser does it, you can't do it, right? And there's other things where like clearly a browser can do it more efficiently than you can. So like animation, like CSS animation will always perform better than what you can do in JavaScript. But things like templating, there is so much opinion in templates, right? So much opinions and trade-offs and semantics that I think it would be a horrible idea for browsers to like standardize templates, because like, look at the templating systems we have so far, they're all inventing new things. They can't decide on the best way of doing things. And I think that, a lot of people look at it like it's frustrating they can't decide. Like I look at it of like, well, I think we just haven't figured out all of the constraints yet. Like we don't fully understand the problem, which is why we're in this world where everybody keeps like re-implementing and redoing things that like kind of look the same, but it isn't. And I think in situations like that, standardizing it is a bad idea, because fundamentally what we're saying is, as an industry, is like, we don't understand the problem, right? And the worst thing you can do is standardize on like a problem that is not well understood.
Yeah, I agree with that. Yeah, there's talks about JSX in the browser, and that's like, that's crazy. Sammy, do you want to throw in something? We're getting close to time. We can go over a bit.
Yeah, to bring it back to something that Mitosis has that Steve, you touched on a bit, and it ties into this templating idea, the fact that like, do we even want one way to template things? Probably not. Different people have different flavors they like. There's different, depending on what kind of app you're building, you might want some things to be, more shortcutty or more like spelled out. And the fact that Mitosis has this separation of syntax to actual intermediate representation means that like, we could just have people build their own syntaxes for Mitosis. They could just be like, well, I really love how Svelte, you write components in Svelte. I think that's really neat and much easier than this like weird JSX thing. I don't care for this JSX thing that Mitosis decided to do. Well, the JSX thing is just a parser. It just takes some string that you write in a file, converts it using this Mitosis JSX parser into a JSON. And then the JSON, once you have that set up, it will get converted to like 15 frameworks. So if you like the way Svelte does things, you can just have this Svelte-esque Mitosis syntax, write a parser that says like, okay, well, this is the code that's going to be on mount, this is on update, this is the state, this is the props. And you're still going to get all of these web frameworks out without sacrificing anything. I think that's another thing that, could be cool, is once we start seeing more people coming in with different syntaxes, we could have multiple parsers for Mitosis and different teams building with different parsers building Mitosis components that ultimately render to every single web framework the exact same way. And you just have this separation of kind of concerns. These web frameworks have been concerned with the syntax, how it gets parsed, how it gets generated. And now we have this like, we kind of like splitting that up so that people can just focus on what they want to focus on, and then have other parts just like be iterated on until we find like the best solution or have multiple solutions.
Yeah, that's where, I always had this dream that like, yeah, we can stop fighting about syntaxes, and you can actually have people working on the same code base where one person theoretically is using the Vue syntax and then writing it in. The only caveat there is purely, how are you going to do GitHub diffs? There's got to be some basic, agreed upon syntax, then others can like visualize as one way. But what I think is cool is that's actually how Builder works too. Builder has a JSON representation for content, and there's multiple ways of visualizing the same JSON. So if you want to be working in a drag and drop or in a more code oriented type thing or whatever, you have those options, which is a lot like any GUI system works. And Mishko, I think you had something. Sorry, I thought you were unmuted on accident. Didn't realize you had something. So please jump in.
Actually, you said a bunch of magical words that triggered me. And so I always like to get on a rant on this particular topic, which is that syntax is stuff that people understand. And so people love to argue about syntax, right? But actually, syntax is in a lot of ways completely inconsequential. The thing that matters is the semantic, right? Like, in which order do things happen? When exactly do things execute? How many times do they get reevaluated? When exactly do the DOM updates, right? The difference between what you love about a particular framework and what is performant or not really doesn't come down to syntax. It comes to the semantics, or rather the meaning of what's behind this stuff, right? And yet syntax is the thing that we will argue all day long, and we were completely ignoring that the semantics is the real thing that really matters at the end of the day. And so, this is just my little soapbox that I always get on when people are like, "Oh, we should make syntax like this." Like, you know what, make syntax whatever you want. Like, that's not the thing that, on the end of the day, is going to either break or make the project. But the semantics very much will break or make the project. And yet, when I go to Twitter, etc., people will endlessly argue about syntax, and there is no mention whatsoever about the semantic meaning of what you have just written in this particular flavor of the syntax you like, right? So syntax is I like to joke that syntax is the bike shedding of the web. Everybody will endlessly argue about that, and yet that's not the thing that really matters.
It's true. And the fortunate thing is that's what people stare at all day, every day. They're staring at a certain syntax. They just want to be different. But that's why I like the LLVM architecture. It's just like, it doesn't give a dang. You invent a language called Rust, doesn't matter. It goes down to the IR and then it handles it from there. And so maybe we'll see that. I mean, maybe there will be a day where, I mean, with Mitosis, I mean, that is our answer. We get issues opened up, but they're like, oh, what about a more svelte like thing? We don't have to argue at all. We just like, cool, send a PR. It's like, if you don't have that syntax, we don't have to argue over it. It's nice to separate those things, but we will discover, to your points before, Mishko, we will definitely discover. I mean, I hit that wacky, there's the infamous, Ryan pointed out with a good experiment. There's an infamous example of how it's basically impossible to use set interval with React and React state with hooks. You just can't. It's just, you just have to deal with that, live with it. And I had that with global event listeners. I just want to have a simple on mount hook, add event listener to the document to listen to clicks outside of a pop-up or like an interstitial. Not going to happen with React. Testing through. Now, the nice thing is we have an end-to-end testing setup that can catch this for us with Mitosis, which is amazing. It catches those edge cases and you can go, oh, I just need an alternative way of writing this thing. So that helps a ton. But that was annoying. I was like, wow, I can't do any of these patterns if we're going to support React. That's unfortunate. And you just deal with that. But we can add sort of layers and stuff like that too. And to circle this back to browser implement the LLVM thing in it. Yeah, maybe. Sorry, I was reading a question. Question just came up. Is it possible for the browser to implement the LLVM thing in it? Maybe. That would be really interesting. I mean, the funny thing is, I think when any project is popular enough, it starts coming up like, could this just be built into the browser for those cases? Like, one of my favorite recent ones is structured clone, right? You can just throw away your own clone deep, function that's bloated and just use the built-in browser one. It's faster, it's less JavaScript. It's amazing. And so as Partytown starts getting popular, people start asking, can this be built in the browser? And that's another one where we're kind of like, yeah, please. Like, we're not trying to, like, this thing is a lot of work. We'd rather just, the browsers could run third-party code in a web worker. We can move on with our lives. That would be amazing. It just takes quite a lot of time, and we need to prove out the patterns and stuff. So if this gets proved out, that'd be amazing. If there one day is one rendering model for the web, maybe. That would surprise me if there ever is with all the innovation going on. And to circle it back to web components before we call it a day, I mean, the irony to me, just to round out the conversation on performance, is, I love the idea of browser native stuff. And I will say that I was using Lit recently because I was doing benchmarking on it, and I was writing the Mitosis output to Lit. And Lit is incredibly small. It's awesome. I mean, it really does lean on browser features. It adds a template system that's incredibly small and light. So if you just have the most trivial Lit components that just hello world, it's wildly fast and optimized. There's just nothing else in there that doesn't absolutely need to be. So I think that's why some people love it. They're like, good. And these simplistic examples, look how great it is. And it's true. Hello world is very fast with Lit, assuming you don't care about server-side rendering. And they'll have a solution for that. And it'll probably only work with Lit, so it wouldn't really connect to other frameworks, but whatever, we'll see. Stencil did similar. And we know Adam firsthand, what those trade-offs and some significant drawbacks were. But the problem is real applications are not hello world components. Real applications are just riddled with business logic and dependencies and stuff like that. And, that's why we're building this benchmarking tool that I linked to in the comments, is because like hello world comparisons for frameworks or rapid insertion of table rows are, in our opinion, not the one and only benchmark to use. How does the framework help you with real applications, and how can it do things like quick or React server components to make sure stuff just doesn't run in the browser? All that million, like the builder web application is multiple millions line of code. That's in a React app. That thing is a nightmare to make sure it doesn't bog down. That thing could bog down. We just sneeze the wrong direction and that thing gets slow. And we have to go in and add different dynamic imports and look in. because it's just over executing everything. Whereas with Quick has what Mishko mentioned as a macro optimization, it just wipes that out. It just doesn't have to run in the browser. Marco does some cool tricks for that. Wiz for ages has been doing cool tricks for that. So I think we'll see more and more of that, and I'm excited about that. And while we end the stream here, thank you everybody for chiming in, commenting. I hope we got to answer most, if not all, of these questions. And always follow up with us. We have a Discord you can find in any of our GitHub READMEs if you want to follow up with more questions there. We have a Mitosis related room there, quick party time, all of that. So anyway, thank you so much, everybody. Topic next week is TBD. We'll figure it out and we'll post on Twitter what that is. So we'll catch you next time, and see ya. And thanks, Sammy, for coming on.
Of course. Take care, guys.